Hey guys, welcome back to another math video. Today we're going to be going over how to integrate with trigonometric powers. So bring you a little closer here. And so you can see that today we're going to be integrating sine to the ninth cosine squared, the x. And so kind of your rule of thumb is when you have an odd power, you're going to kind of take it, split it up, and then convert all of it but one to the even power, and then do a u sub from there. So let's begin. So I'm going to come over here. So our first step for this integral is going to be to just do some algebraic simplification, okay? So we can rewrite this as, okay, sine, and we want it, okay, so we could do sine squared x to the fourth power, right? Because when you're raising an exponent to an exponent, you're going to multiply the exponent, so that's sine to the eighth. And then if we just multiply this times sine x, we can see that now this is the exact same thing as sine to the ninth of x, just in a slightly easier to understand form. Now we're going to have our cosine squared x, and of course dx. Now we're going to use our trig identity, right? So we want to convert this to cosine, and we know that if sine squared x plus cosine squared x equals 1, thus we know that sine squared x equals 1 minus cosine squared x, right? And so now we're going to implement that. Now with said substitution, we can see that the integrand, we can see that now we have 1 minus cosine squared x, all raised to the fourth power, times sine x, times cosine squared x, of course dx. Okay, now a few things we notice, right? We see that cosine and its derivative sine are here, and so we now can see that a simple u substitution is going to work to simplify this. So setting u equal to cosine x, du equal to negative sine x dx, and thus du over negative sine x equals dx. So now once we implement this, we can see that integral of 1 minus u squared to the fourth power, to the fourth power, times, so obviously this is going to get canceled with this, or I'll actually write it out for you guys, times sine x times u squared over negative sine x du, right? Now we can see these cancel, and this just becomes negative integral of 1 minus u squared all to the fourth power times u squared, okay? So now this is a pretty easy integral to solve. However, we have to deal with this 1 minus u squared to the fourth power, and according to PEMDAS, we have to do exponent first before multiplication, right? And so to do this, unless you know your binomial expansion pretty well, this is pretty difficult, right? And so the easiest way to do this is with Pascal's triangle of coefficients, right? So we do, it starts with 1, 1, then it has 1, 2, 1, then it has, it has 1, 3, 3, 1, then it has 1, 4, 6, 4, 1, right? And this is going to be n equals 0, this being n right here, n equals 1, n equals 2, n equals 3, n equals 4. And this is the one we're looking for, right? And so if we wanted to test this, okay, what is x plus 1 squared, right? That's going to be x squared plus 2x plus 1, okay? So now to implement that using this, because we have this negative, we know it's going to alternate every time. So we're going to start with, I'm actually going to kind of reverse this and write this as almost negative u squared plus 1, kind of make it a little more clear here. Doesn't change it. So now we're going to have u, okay, we know it's going to just be a coefficient of 1. And if we're multiplying 2 4 times out, so we have 2 times 2 times 2, we're going to have a u to the 8th minus 4u to the 6th plus 6u to the 4th minus 4u squared plus 1. Obviously, we can see that. And so now we have this, right? And now through this, we're going to have to distribute u squared into each term, okay? Thus, this becomes, and remember that when we're multiplying, add the exponents, this becomes u to the 10th minus 4u to the 8th plus 6u to the 6th minus 4u to the 4th plus u squared. Okay? Now, we're going to rewrite our integrand. And I'm actually just going to use this. And remember, the whole thing's negative. And we'll have a slap our du on the end, right? Now is the fun part. Now we get to anti-differentiate, right? So now we're going to have negative u to the 10th. Okay, that's going to be 1/11th u to the 11th minus 4u to the 8th. So this is going to be minus 4/9 u to the 9th plus 6th 7th u to the 7th minus 4/5 u to the 5th plus 1/3 u cubed. Okay? Now, if you may be saying, oh, why don't you have the plus c? Well, I'm not going to write that yet due to the fact that we still haven't put our u back in. Remember that u is equal to cosine x. Okay? So now comes the final part. Negative. Make sure you guys can see this here. Negative entire thing. We're going to have cosine to the 11th over 11 of x minus 4/9 cosine to the 9th of x plus 6th 7th cosine to the 7th of x minus 4/5 cosine to the 5th of x plus 1/3 cosine cubed x plus c. And let me scoot this back so you guys can see the solution. And as you can see there, that is our solved integral. Scoot it back even a little more. Well, and I'm going to rewrite the solution one more time up here so everyone can see it. So, do some erasing work here. So, erasing all of our steps. I know that this is going to be equal to, make sure you guys can see that. Bring it back in the frame here. This is all going to be equal to cosine to the 11th of x over 11 minus 4/9 cosine to the 9th of x plus 6/7 cosine to the 7th of x, okay, minus 4/5 cosine to the 5th of x plus 1/3 cosine cubed plus c. And that's the solution, guys.
Slay!
Thanks.